Hello guys, welcome back to my channel. In this video we will learn about physics और आज हम पढ़ने वाले हैं एनर्जी जो कि क्लास 8th स्टैंडर्ड की होने वाली है। सबसे पहले मैं स्टार्ट करूंगा वर्क से। तो चलिए देखते हैं वर्क क्या होता है, फिर हम अपने चैप्टर को आगे कंटिन्यू करने वाले हैं। Let's see what is work. So first I have some definitions of work. So let's see first one. So first one is little lengthy, then second one is little small, and third one is the smallest. Let's see first one. So first definition here is work is said to be done when force is applied on the object and it changes its position in the direction of force. This is the first definition. Let me write it for you. And you can also take a note of it. Work is said to be done when force is applied on an object or on a body object and the object changes its state of or its position. Okay. Or you can also write that work is said to be done when force is applied on an object and the object changes or object moves in the direction of force. You can write this also. Let's see the second definition here. So the second definition can be work is said to be done when force is applied on an object and the object displaces in the direction of force. This is like the first one, only little things, some things are changed. Let's see. And let's write, or else I should leave it. Okay, and now let's see the third one, which is the smallest. Here we see that work is the product of force and displacement. This is the shortest and easiest, and from this definition I can conclude that we have the formula of work. Let's see first. So work is said to be done, or wait, work is the product of force and displacement. A product of force and displacement. Now let's see the formula, but before that we should see the SI unit of work. So SI unit of work is, so SI unit of energy is joule. So work is like energy only. We will discuss energy also. So we get from here, we get that SI unit of work is joule. So if you write J, in short you can write capital J. That is enough. And now let's see the formula of work. So formula of work. Okay, here in the second definition we see product of, the product of force and displacement. If you don't learn the formula, you only learn this definition, you will easily be able to solve the numericals. Now product of force into displacement, here we can write F into S or F dot S. Here this dot is represented as multiply. Now let's see some conditions when the work is said to be done. From here we see conditions by which a work is done. Still we have learned that formula of work, SI unit of work, definitions of work, and easiest one. And now we will see condition when a work is done. First condition here is that work is said to be done when force is applied on it. Here we see the definite formula, force into displacement. So force plays an important role in work done. So force should be applied on an object. Force should not be zero. Not be zero. Here F is equals to 0. F should not be equals to 0, right? And if we see here, this is a box. Okay, this is a wooden box. It is on ground. Okay, here a force of 10 Newton is acting from its left side, and on the right side 10 Newton of force is also applied. So here the force is equals to 0. So work done is also 0. And if it is the second point, that is displacement should not be also 0. Displacement should not be 0. It means S is not equal to 0. Here S is represented as displacement. So in this, like, we again take a wooden box and keep it on ground. From right side 15 Newton of force is applied. Okay, and from this side 10 Newton of force is applied. So here force is not equal to 0. It is S equals to 5 Newton. Means 5 Newton of force is applied from right side. Now when more force is applied from the right side, the box will displace to right side. So here S is also not equals to 0, and we conclude the second point is also true and the first point is also true. Means force should not be equal to 0 and displacement also should not be equal to 0. And now let's see on energy, or let's recall or recap energy, and then we will see a type of energy which is mechanical energy. Okay, let's see that. So guys, now we will look on the next topic, which is energy. Now what is energy? Here energy is the ability to do work. So from this definition I conclude that work is related to energy. Now let's see the SI unit of energy, and then let's see the SI unit of energy. Which is equals to joule. As you all know, it is equals to joule. And energy, work is related to energy. So SI unit of work will be joule, and energy, it will also be joule. Now let's see on our main topic, which is mechanical energy. Mechanical energy. Now what is mechanical energy? Here the energy possessed by a body or by an object due to its state of motion or its state of rest is known as mechanical energy. Now let me write it for you, and you can also note it. Now mechanical energy, the energy possessed by a body or an object due to its state of motion or rest is known as mechanical energy. Okay, is known as mechanical energy. This is a type of energy. So SI unit of mechanical energy will also be joule. Now let's look the type of mechanical energy. You have studied two types of mechanical energy, that are kinetic energy and potential energy. Let's look on them. Now guys, we will look on potential energy and kinetic energy. First we will see on kinetic energy. So what is kinetic energy? Here kinetic energy is energy possessed by an object or a body due to its state of motion. When an object is in motion, it possesses kinetic energy. And let's write the definition, and you can also note it with me. Now kinetic energy. Here kinetic energy is also represented as Ke, which is kinetic. K stands for kinetic, E stands for energy. Now what is kinetic energy? As I told you, the energy possessed by a body due to its state of rest, its state of motion is known as kinetic energy. And now we look on the formula and SI unit. So as you can see, it is kinetic energy. It means joule. Now we look on its formula. Now let me write SI unit is equals to joule, which is very simple and understandable, that if SI unit of energy is joule, work is related to it, it will be also joule. Mechanical energy is also related to it, and mechanical energy has two parts, kinetic and potential, so both SI unit will be joule. Now let's see formula for kinetic energy. Formula. Now it's for kinetic energy. Potential energy also we will discuss in the same video. Now formula, it will be half, it means 1/2 into m into v, which is 1/2 mv square, with all is in multiplier. Now what is m? What does m stands for? Here m stands for mass. It means if it is given a numerical, then in that numerical either the kinetic energy will be given or mass and volume. So here m is mass, and so it is not volume, I am really sorry, it is velocity. Now in the question it will be given either the kinetic energy or mass or the volume of a velocity of an object. Now let's look on potential energy. So guys, now we will look on potential energy. So what is potential energy? Actually, kinetic energy, we saw the energy possessed by a body due to its state of motion is known as kinetic energy. Potential energy is opposite of that. Means when an object is at rest, then it possesses most kinetic energy, the most potential energy. Kinetic energy is that time 0 and the potential is the most. And here we say that potential energy is the energy possessed by a body due to its state of rest. Now let's write for you, and you can also note here potential energy. And potential energy, which is P dot E. Here P stands for potential and E stands for energy. Now what is potential energy? As I told you, the energy possessed by a body or an object due to its state of rest is known as potential energy. Now, as I tell you that we have now potential energy is classified into two types. First, the gravitational potential energy, and the second is elastic potential energy. It is a more type, but we will discuss only of two types. Others you will learn it about in the higher classes. Now let's see first gravitational potential, or you can simply write gravitational PE, which is gravitational potential energy. Now, what is gravitational potential energy? It is actually this. The energy possessed by a body due to the state of rest is known as potential energy. The same thing is the gravitational PE. It is the same. Now, let's see the formula for gravitational potential energy. As you know, it is energy, so SI unit will be joule. There is no confusion in that. Let's see the formula for it here. Formula will be mgh, means m into g into h, which is mgh. Here mass, m stands for mass, g stands for acceleration, due to gravity. That's why we say it gravitational potential energy. Now, h is for height. Now, one thing you see here, you will be given the mass, the height, or you will be given the potential energy, and one will be missing here. Gravity, g, acceleration due to gravity. Actually, it is 9.8 meter per second square, but we generally, to solve questions or to make them easier, we take it 10 meter per second square. So it is 10 meter per second square. So you can note this. This is the main point. So to solve questions, we take this, not this. This will make your question difficult. Okay, but standard, the main is 9.8. But for solving question, you can take it as 10. You can round off and take it as 10. Now we will look on the second point, that is elastic potential energy. Elastic potential energy. What is elastic potential energy? This is some different from gravitational potential energy. Actually, the formula for it, you will learn it in the higher classes, class 9th or 10th, but I will tell the definition for it, very small, smaller than this. It is actually the energy possessed by elasticity of an object is known as elastic potential energy. So, the energy possessed by the elasticity of an object. Elasticity of an object. Here it is also related to energy, so it will be joule. SI unit will be joule. And now let's see the next segment of our video, which is transformation of energy from kinetic to potential and vice versa.